All right, so just running through page 373, question 8 real quick. Question is, find the equations of the lines which are parallel to 15x plus 8y plus 7 equals 0 and which are 3 units distant from this line. So I've got this line 15x plus 8y plus 7 equals 0. And then I've got two lines. So the equation of the lines, there will be two lines which are 3 units distant from that line. Okay, so there'll be one which is 3 units out this way, and there'll be one which is 3 units out this way. So you're trying to find the equation of these two parallel lines. The equations of these lines will be in a very similar form to this one. They will also be 15x plus 8y plus, the constant will change, okay? So plus just some other letter, plus k, or plus, yeah, if I use k. Okay, so it will be in this form, and this one as well will also be 15x plus 8y plus k equals 0. The k will just be different for both of them, okay? So it will be the number only which changes, all right? So I'm looking for this letter here because I'm looking for the equations of these two lines. So I'm going to use the perpendicular distance formula to get the equations of these lines, because I know the perpendicular distance from these lines to the line that I have the most information about, okay? When I'm trying to get the perpendicular distance between two parallel lines, you need a point on one of the lines, okay? So I'm going to get a point on this line, and it can be any point at all on that line, because that perpendicular distance from this line to these will be constant, okay, because they're parallel. So I'm going to get a point on this line. I think the easiest ones to get are always sub-0 in for x or sub-0 in for y. All right, so I'm going to sub-0 in for x here, and I'm going to get 15 times 0 plus 8y plus 7 equals 0. 15 times 0 is 0. So 8y equals, I'm going to bring the 7 over, it becomes minus 7. So y is equal to minus 7 over 8. So when I sub 0 in for x, I get minus 7 over 8 for y. So 0 minus 7 over 8 is on that line, okay? Look, you can tie yourself up in knots trying to find a point on this line where one of the coordinates is not a fraction, but I would say just deal with the fraction when you sub into the formula. And also the fact that one of the coordinates here is 0 will make it easier when I come to use the perpendicular distance formula, okay? So 0 minus 7 over 8. I also could have sub 0 in for y and got the x that goes with that. Could have subbed anything else in for x and get the corresponding y, anything in for y, get the corresponding x, but like I said, I think 0 something or something 0 are the easier ones to deal with, okay? So what's the situation I have here? 0 minus 7 over 8 is the point I have on this line. So 0 minus 7, 8 is 3 units from 15x plus 8y plus something equals 0. So this point is 3 units from this line and this line, and I know the equations of those because they're parallel to this one will be in this form here. So the 15x, the 8y the same, just the constant that is changing. Okay, so I have everything then I need to use the perpendicular distance formula. So your A, B, and C you get from the line. So your A is 15, your B is 8, your C then is K. Okay, so that's the only unknown you're going to have in this formula. Your 0 minus 7, 8 are your x1, y1, and your 3 units then is the answer you get when you use the formula. Okay, so the perpendicular distance, which I know is 3, is equal to the absolute value of A times x1, so 15 times 0. So that's just going to be 0. That's the advantage of getting a point with 0 in it. Plus by, so plus 8 times minus 7 over 8. And even though I ended up with a fraction in that point, what's actually going to happen here is that's going to cancel out nicely for us because I'm multiplying by 8 and I've got over 8 in here. And then it's plus c, so plus k. That's what I'm going to be solving for. All over the square root of a squared plus b squared, so the square root of 15 squared plus 8 squared. All right, so 3 is equal to 15 times 0 is 0. 8 times minus 7 over 8 is just minus 7. So the absolute value of minus 7 plus k over 15 squared is 225, 8 squared is 64, 225 plus 64 is 289, square root of 289 is 17. Yeah, okay, so all of that square root of 15 squared plus 8 squared ends up being the square root of 289, which is 17. So you just end up with 17 on the bottom there. All right, bring the 17 over then. And it becomes multiplied by 3 times 17, it's 51. So 51 is equal to the absolute value of minus 7 plus k. You have two choices here. You can either square both sides. So you need to get rid of the absolute value signs or certainly deal with them. So you could square both sides. You'll get a quadratic. Solve that. That will give you your two possible values of k. That will give you your two possible equations of the line. Or else, another way of dealing with the absolute value signs is to deal with the positive and negative case separately. So this means that minus 7 plus k must be equal to 51, or else minus 7 plus k is equal to minus 51. Because if you got minus 51 inside this absolute value sign, the absolute value signs will turn it into plus 51. So the equation would hold. So minus 7 plus k is equal to 51. Bring the minus 7 over, becomes plus 7. 51 plus 7 is 58. So k is equal to 58. Over here then, bring the minus 7 over. It becomes plus 7. 7 minus 51 is minus 44. So k is equal to minus 44. So there's my two possible values for k. Just pay close attention to what the question wants. Find the equations of the lines. So just go back to these equations and sub your k's in. So your answers are 15x plus 8y plus 58 equals 0. Or the other line then would be 15x plus 8y instead of k minus 44, so minus 44 equals 0. So there's your two answers. All right, so that is page 373, question 8.